Though the greenhouse effect is a natural and necessary process that we've needed, what we don't need is the enhanced greenhouse effect. So this is where more than 80% of the heat is trapped in the atmosphere from greenhouse gases. So what we know so far is that this carbon dioxide, the most important greenhouse gas, but not the only one, this contributes to higher temperatures, and that this concentration of carbon dioxide has been increasing over the past century, and it is from human activities, anthropogenic. So this is all thanks to carbon isotopes that can link the concentrations of carbon from 1,000 or 100,000 or even 1,000,000 years ago from ice core data, and also let us know that it's new carbon that is produced in the carbon. It's new carbon in the carbon dioxide. It's not been around for 100,000 years. We're also using hydrogen isotopes to link temperatures through the 1,000 or 100,000 or 1,000,000 years ago, and this is also in light of we can use current temperature recordings to note that the temperatures have increased just over the past century. So the question is, what is it that we don't know? What will happen in the future? And that's thanks to climate modeling. So in climate modeling, this is predicting what will happen as far as temperature, and a lot of factors go into predicting future temperatures of Earth. So the factors are called radiative forcings, and it is taking into account the incoming heat that we get from the sun and outgoing heat. And a lot of things go into this. So looking on the x-axis, these are 0, 1, and 2. Those are the positive numbers, and then there's 0 to -1. Those are the negative numbers. So there are positive radiative forcings, and these cause heating. These cause warming. And then the negative cause cooling. So there are warming effects and cooling effects. And we can see in general there are more warming effects, but there are also cooling effects. Okay. On the y-axis, there are these forcings are both natural, but also anthropogenic. So that means human caused. Okay. And we can see that most of the forcings, most of these factors that affect the models are anthropogenic. They're caused by humans. Just a small amount are natural. Really just this one. And so this one, starting down here, are changes in solar irradiance. So this is just random fluctuations of the sun. Sometimes the sun sends out flares, and this is going to cause heating. Okay, so that's on the plus side. So looking at the cooling effects, that's the next, these are negative anthropogenic. Clouds are the biggest question mark. So clouds are a real question mark. So there's a big kind of error, because clouds do cause cooling. And the question is, will there be more clouds because there's going to be more evaporation and to create more clouds when there's more heating? So this is a term here on this called albedo change. Albedo is reflection off surfaces. And so this actually has a negative effect, and this is because as humans take up more land space, less darker spaces and more lighter spaces, like more sand, perhaps, and so this would be a negative effect because sand being lighter can reflect off more of this incoming radiation. So of these negative effects, there's also aerosols like dust. Those create more clouds, and that leads to more question marks of more clouds, because clouds can cause a cooling effect. So we can see, though, the majority of these are anthropogenic, and they're warming effects. They're on the positive side. And all of these up here, this is the biggest one, is carbon dioxide. This has the greatest warming effect, and also has a huge question mark for the error bars. Not as large as the clouds, but still. It just depends on how much carbon dioxide is going to be emitted on top of the carbon dioxide that's already at 400 parts per million. So we have, these are the greenhouse gases. We know that carbon dioxide, methane, and chlorofluorocarbons, these contribute to warming because of the molecule shapes. So albedo, this is reflection off surfaces, and albedo can have both warming and cooling effects. Mostly cooling though, if the reflection is off of snow or sand. So what happens though when the polar ice, the North Pole glaciers are melting, as well as the South Pole? Warming effects there, because when ice melts, then you have a darker ocean water, and so ocean does not reflect off as much, and neither do these darker trees and forest or grassland. And so this is all kind of unknown exactly how these variables will come into play. It depends on what humans do. So we've got, this is what snow does, reflects off from all the reflection of sun from the snow onto your face if you haven't worn sunscreen or sunblock. Sand also has lots of albedo, or reflection off the surface. And so these will cause question marks about clouds, because clouds, will there be more clouds when the atmosphere warms? Ultimately, clouds are still very much unknown. So climate models are used to explain the temperature increases experienced in the last 30 years and then predict future temperature increases. So natural factors have influences, and those are called those natural forcings. And then there are also anthropogenic forcings. Those are the human caused, and those generally have a greater effect. The pink and purple take into account both natural and anthropogenic, so natural and human caused, and over land or land and ocean or just the ocean. All these models show 1 to 2 degrees Celsius, which translates to about 2 to 4 degrees Fahrenheit roughly. So in terms of what we don't know, or predicting what's going to happen in the future, is basically we can't say for sure, but what might be true is that there's going to be continuing carbon dioxide and more greenhouse gases, all generated by anthropogenic or human activity, and this is going to cause temperatures to increase, and it's going to continue to increase as we have more greenhouse gases. Why is this important to see? Because we can't see it. The average citizen anywhere in the world cannot see any of these greenhouse gases, can't see these carbon dioxide molecules. You can only really understand it if you understand the molecule shapes that we just studied in chemistry. And the other thing is that we can't see these effects happening at the North or South Pole because we don't go there. But we know that global warming is not uniform, and we know that this is happening.